or x. So what do you end up with? You end up with this. What's the limit doing? The limit as h goes to what? The limit as h goes to 0. So the table you make looks like this. I would make this table. This is the fantastic table you make right here. This is what you're plugging values into. As h goes to 0, you're getting closer and closer to x equals 2. As h goes to 0, you're getting closer and closer to x equals 2. So you fill in this chart right here. 0 is, you're on the point, you don't calculate that, but you do 0.1, 0.001, 0.01, and 0.1. Here's the thing. Why are these negative? Why are these h values negative and why are these positive? Why are these negative and why are these positive? Yes?
Because we need something on both sides.
Yes, you want something on both sides. If you want to go to the left of a point, you have to subtract values from it. If you want to go to the right of an x value, I'll be more specific, you add values to it. Now, this is a table, but you can't really use the table set on your calculator to do this. Why not? Why can't you use the table set and like make a table? Why would it be a little challenging to use a table? What's the distance between all these? Is it the same? They're different, right? So theoretically you could, but you're going to have to scroll a lot. You'd have to start at negative 0.1. You could scroll. You can do it, but the thing is, if there's more, it would be really hard to scroll that far. So instead of making a table on your calculator, which you could do still, you could, instead, what could you use instead? Yes. So what does y equal? Oh, that's a different one. In this case, what was it? It was parentheses 2 to the what? Oh, now we have the same problem before. It's the whole resolution thing here again. I can't get to the enter buttons, but you would enter the function here. Like, I'm going to use a different one, okay? Just because I can type something in, maybe if I can get a number here. I can't here. Great. I'd like you to use when you're doing this with a table are right there. 1/100th on each side, and then 1/10, and well, sorry, 1/1000, 1/10, and 1/100. Someone asked in the last class, what's the point of doing it on both sides? Anybody want to guess? What's the point of doing it on both sides? Or what's the point of doing these four at all? Why don't we just do one of these, or really close? What's the point?
So that you can get
So you can get a what? Well, like, why don't we just do this one? Like, that's close, right?
Well, you don't know how far.
Like, you don't, exactly. You don't know how far. You don't know what, like, the overall behavior is. This gives you a really good trend on both sides. Like, both sides are going to this, right? Both sides are going to this. Now, could you get even closer than 0.001?
Yeah.
Absolutely. That's what your calculator can do. The thing is, this is just an estimate, right? What's the only method we have that's exact? Not graphically, not numerically. Algebraically. Here's the thing. Are you able to do all of these algebraically? No. Like this one, we did this last class actually. You run into a wall. You get to a point where you can't cancel the h's. Like if you do the algebra on this, there's no good way to get rid of that h. You don't have the algebra to do this. So what's the only method you have right now to estimate this derivative? Make a chart. Use a chart. Absolutely. Now the next one, which I'd imagine most of you might want to do, take a look at the answer key when you have more time. This is just the exact same thing with a different function. It's the exact same process with a different function. So what do we have? Always start with this. Literally write that down and then say, what's the a value this time? Well, the a value this time is 0. It's a different function. It's -3 to this x plus 1 plus 4. So is it really easy to mess up the algebra? No. Yes. Be super careful with the algebra. What you're doing is this right here. Does that look familiar? Kind of like what we did before, right? Can you simplify this? No, can't go any further or any meaningful further distance. So then you use this to make this table. You see this table right here? And look, it gets real close to one value. You have to be very careful about this though. Be very, very, very careful about it. It is super easy to get the algebra wrong. Okay, so let's go on right here. So what do you have coming up?
A test.
A test. You have a test, a test, a test. This, you would see something like this. You'd have this, and then down here at -2, right? And -2, and it would go up like that, right? So where does 2? Well, let's see, you plug in 2 there. It's 2, when you plug in 2, what do you get? 2, 2, yeah, 2, 2. If you do the tangent line right here, if you did the tangent line right here, is that positive or negative slope?
Positive.
So it's going to have positive slope. Now, how would we find this algebraically? How would we find this algebraically? What's the phrase? What's the thing I want you to write down first? What's the thing I want you to write down first? Nope. Start from the beginning. Limit as 0 of f of a plus h minus f of a all over h. This has to be automatic. You have to just like muscle memory that out immediately. The difference quotient is king right now. What's the a value now? 2. And what's f of x equal to? What is it? It's right there in front of you. What's f of x equal? No. What is the function? It literally is at the top of the board. X squared minus 2 is the function. I want you to start these with that information so that you have a consistency of presentation. So now it's literally plug it in. So you have limit as h goes to 0 of f of 2 plus h minus f of what? 2 all over h. But what is it? Oh, f is x squared minus 2. So what does this become? The limit as h goes to 0 of what? What's squared?
X.
Nope. 2 plus h squared minus 2 minus what? 2 squared minus 2. Don't simplify yet. All over what? All over what? H. Take a look at that. Simplify. So let's do that. So we end up with the limit as h goes to 0 of, what is it, 2 squared plus 2h plus 2h plus h squared minus 2 minus 4 plus 2 all over h. Anything combine up there? Anything cancel? Well, that 4 cancels with this, right? That minus 2 cancels with that. So what does this become? Can you tell me what this becomes? The limit as h goes to 0 of what? How many h?
4h.
4h plus what?
H squared.
All over?
H.
What can you factor out of the top, Maggie?
H.
Yep, so it's the limit as h goes to 0 of h times 4 plus h all over h. What's the magical thing that happens now?
Cancel.
What cancels?
The
The h's cancel. Is that really nice? Yeah, because now you have the limit as h goes to 0 of what? Which is equal to what? Now let's look. That tells us the instantaneous rate of change is 4 there. Let's look at the original slope here. Is that slope pretty steep?
Yeah.
Yeah, is it positive?
Yeah.
Yeah, so it is 4, or does that match the logic of what we saw there?
Yep.
Now, you can tell me further, on this side, all of the derivatives are going to be what? Positive, and on this side, all the derivatives are going to be? Exactly. And what's the derivative at x equals 0? Like at the vertex. What's the derivative here? No, it exists. The derivative is 0, horizontal line. You are going to spend an inordinate amount of time looking at points where the derivative is 0. You're going to spend a lot, I'm just telling you right now, a little preview of what's to come. You're going to spend a lot of time taking a derivative, setting it to 0, and solving. You're going to do that hundreds and hundreds of times. Critical points are really important. Why? Well, real life functions look like this all the time, right? In a real life situation, what could these points represent? Like maximum and minimum profits? Or like how to do the best at something, or how to do the worst at something, or how to use the least of something? Are those interesting things to know?
Yeah.
Absolutely. You will spend a ton of time looking for points like that. Looking at points like that. Okay, so what I'd like you to do now is I'll count you off. The ARC is always the slope when it's a line. Nice. Negative 2 plus h over negative 2 plus h. So what do you end up with? 2 over 2 times negative 2 plus h plus negative 2 plus h all over 2 times negative 2 plus h. Do we have a common denominator now? We do. So what does the numerator become when we add? H over 2 times negative 2 plus h. Is that correct?
Yep.
So that is the numerator. So that's our new numerator. So where can we plug that in? Right there. So now what do we have? We have the limit as h goes to 0 of h over 2 times negative 2 plus h all over what? H. Dividing by something is the same thing as multiplying by the what? Reciprocal. So what do we have now? The limit as h goes to 0 of h over 2 times negative 2 plus h times the reciprocal, which is 1 over h. What cancels now? The h's cancel, leaving you with the limit as h goes to 0 of 1 over 2 times negative 2 plus h. Can we now plug in 0 for h? Yeah, so what's that equal? What's it equal? 1 over negative 4. So what does that tell you? The instantaneous rate of change is exactly negative 1/4. It's kind of cool.
Wait, can you go to the last step again?
Right here,
So like I have
this step.
I've got